Cybersecurity is a huge challenge today. And, whoops, can we get the clicker working? Maybe if I get another clicker up here. No? Somebody know anything about IT here? There we go. We got a click to work. You know, just when you think it can't get any worse, it does. You know, and these are the headlines just from the last few months. Doesn't even include the ones from the last week or two. For example, the big Uber hack. Really an incredible problem we're facing. You know, and you wonder, how did these companies wind up in the headlines? Were they stupid? I don't think so. I think these companies had smart people working there and working hard to defend themselves. The problem, I think, is that we're up against tremendous adversaries, and not just the prototypical teenage hacker trying to impress their friends. You're up against very large hacktivist groups. You're up against major states, not just groups out of the Middle East or the North Koreans, but some of the world's largest countries have major investments in cyber exploits. And you have organized crime, which is making a fortune from the hacks. You know, I had my tax returns stolen, a false return filed on my behalf with the IRS. Still sorting out that mess, and a lot of Americans in the same boat there. 80 million Americans had their entire medical history taken. You know, recently you have the Equifax, of the 140 million people, you know, their credit history taken. It's incredible, the scale of what's going on and the money and the demand behind it. So we're up against tremendous adversaries, and this is a situation where it's a heck of a lot easier to attack than it is to defend. You know, if just one of your apps is not updated with everything, patched for all the latest exploits, they're going to take advantage of that, and you're going to be in the headlines. And it's just so easy to do. Even the protocols we've relied on for security have incredible vulnerabilities discovered years later after the vulnerabilities actually were implanted. It's so easy today to click on that wrong link or go to the wrong website. You know, here's a domain that looks like it says training.akamai.com. It's actually Akamai. And in fact, today you could even have it say Akamai and really have it cause damage. The spear phishing attacks are incredibly sophisticated. They know who you're talking to online. They know what they're likely to say, and it makes it very easy for even people who've been through the training to click on the wrong link. And it's now being compounded by the Internet of Things. Literally billions of devices coming online that have a full communication stack, fully capable CPU, very well connected. The last mile today in most of the major countries in the world is very good connectivity, and there's no security. And maybe at best it has a password 12345, or a password that people know what it is. And so it's easy to take over these devices, and they're now fully powered computers that can be used to do anything the attacker wants. This is just an incredible problem. And the typical way of defending yourself, buying the latest defenses and putting them in your data center, does not work anymore. In fact, you can't even have enough capacity to keep up with the scale of attacks that are happening today. Whole data centers can be taken down pretty easily at this point, given the Internet of Things. We've seen attacks, you know, at terabits per second, and a single data center can't withstand that. And for you in that data center, even if you could provision all that capacity and buy all the boxes to filter all the traffic, you couldn't afford it. And so the traditional model of defense just doesn't work anymore, and that's why you see all the headlines. You know, the IoT problem in particular is enabling the attackers to assemble massive bot armies and exploiting the bandwidth imbalance on the internet. we think about the internet as sort of the cloud and the core data centers. The capacity we have in the major backbones and the core data centers and the big peering points is at least 2 orders of magnitude less than the capacity in the last mile. Now, today, of course, the attackers do leverage the cloud data centers to launch attacks, but even more, they're getting tremendous scale by taking over the video cameras and all the devices out at the edge, where, in your homes and offices, many of you probably have 40 megs, 100 megs, and the total capacity out at the edge of the internet is now measured in tens of thousands of terabits per second. And this capacity now is available to a single attacker who can assemble this massive bot army and launch attacks at scale against you. We're to the point now where it is possible to isolate countries from the internet because they simply don't have that much capacity in and out of the country or across the ocean compared to all the capacity at the edge of the internet. It's a bad situation. At Akamai, our goal is to keep our customers and ourselves out of those headlines. And one of the things that we have to do is provision massive capacity to absorb these huge attacks. And the way we do that in part is by placing our servers at the last miles of the internet, out at the edge, not just in the core data centers, because there's not enough capacity to defend there, but out where all the devices are, where the last mile and the capacity is, and to absorb the attack traffic there before it gets anywhere near the data center. And it's the same platform that probably most of you know us for, delivering video. If you watch the Olympics or the World Cup or any sporting event, online, there's a pretty good chance that we're actually, giving you that stream, or if you watch movies online, and that takes enormous capacity. And so we use the same capacity to deliver large-scale video as we do to absorb the major large-scale attacks on the internet. Now, it's not just about capacity. You've also got to be looking at all that traffic and filtering out the application layer attacks as you go. And we do that with a capability that we call Kona. And so we place our, the web application firewall and the filtering technology out in those servers. So as all the traffic is coming into your data centers or to the cloud data centers, we're looking at it and seeing, is it trying to exploit something? Is it trying to do something bad? A great example of this would be, the recent Equifax hack that we all read about. And there, the attack was exploiting the Apache Struts vulnerability in a consumer-facing website. And, Equifax, according to published reports, thought they'd patched all their apps and sites for this particular vulnerability. But like most companies, they got a lot of apps and sites. And it is hard to make sure you got them all. And of course, if one isn't patched, you're in big trouble. And this is where having defense in depth is so important today with cybersecurity. And so, for example, just having Kona put in front, Kona Site Defender, and filtering the traffic, well, so we're filtering out all the traffic that's exploiting the Apache Struts vulnerability. And so you're safe, even if you haven't patched all your apps and sites yet. You're covered for that period of time. And if you missed one, for goodness sake, you want to have the extra layer of defense in front. It's so important today. These are just mind-boggling numbers. These are the major attacks, not the normal daily stuff, but just the major attacks on our customer base. Today we have many thousands of customers, and they tend to be the largest entities on the web. So the major banks, the major commerce sites, the major media companies, government agencies would use our services to defend them. But you see the scale here of how fast the number of attacks is increasing. You see the scale of the attacks. Every day we have a customer that's experiencing attacks that's measured in hundreds of gigabits a second. And we have lots of customers experiencing attacks at tens of gigabits a second. Now, that's just the volume. Of course, what also matters is what is the nature of the attack. So you got to worry about both those things. But the scale today is is mind-boggling, and of course growing dramatically. This is getting worse. A lot of people don't think about this, but today the large majority of all transactions on the web are not human. They're autonomous. We think about the web, for example, Cyber Monday, where you go to buy something online and you get a traffic spike, and we think about the human use of the web, or you watch a video, but that's actually the minority now of transactions. Most of them are bots. And people hear the word bot and you think bad. Actually, that's not true. A lot of the bots are good. Some are in between, and of course there's a bunch that are bad. Today we track tens of thousands of types of bots that are out there. Many of them reveal themselves as to what they're trying to do. For example, search engine bots. They're good. Most of you have, consumer-facing websites. You want to give that Google bot really fast service and make sure all the right keywords are there. And then your search rankings go up. The last thing you want to do is block the Google bot. There's, a lot of different kinds here. And in fact, how you want to respond to the bot depends on its type. A lot of folks think, okay, bot is good or bad, and you just block it or not. In fact, you want to give all different kinds of responses on the fly based on what the bot is doing. For example, Googlebot, fast response, right content. Today price scraping is ubiquitous. Most any commerce site, and a lot of folks don't know this, even that run the site, almost all their traffic is bots. And it's price scraping is a huge part of it. Now, it might be friendly price scraping. It might be an aggregator, and you want to, service that. Most often it's not. It's your competitor. And as soon as you change a price or you put on a little sale, within seconds they want to know. So they are pounding your site to find out, what all your prices are, because they want to undercut it. And so they'll show up on the aggregated sites as always being the lowest price. It'll be a penny. And sometimes you see this in travel sites and stuff. You get the bunch of the prices, then there's the guy who's a penny less. And of course, as soon as you changed your price, they scraped it, found it, and put their price in. This is really damaging for things like the airline industry, because every time you do a query to an airline reservation system, that costs them about $1. In fact, the biggest cost for airline and travel sites is what they spend to the airline reservation system, and it's not based on TicketSpot, it's based on somebody did a query. And so the majority of their cost is not running their site. It's actually the money they spend on the reservation systems, and almost all of their traffic now they're discovering is bots. Total waste. It's, of course, you've got advertising fraud is now about a $10 to $15 billion industry. Bots hitting the ads, to cause expense. Probably the worst of all today are the account hackers. And today we see across our customer base that 2/3 of all login attempts, just logging in, they're not human. They're bots. And what they've done is they've stolen credentials somewhere else, and they're checking those credentials on thousands of websites. Because let's face it, I'd be surprised if any of you uses a different login on the 100 sites you log into, for all 100, all right? There are automated systems you can use that do the login for you, that make it easier, but most people don't, and they reuse their credentials. And so the bad guys know this, and when they steal it on a Yahoo breach or an Uber breach or whatever, then they try it on thousands of sites, and they spam the site checking it out. And the trouble is these guys are really sophisticated now. It's just logging in, so there's no malware, there's no thing you can tell by inspecting it that it's bad. And they've gotten clever enough where they're not using one IP address to do 100 logins per second. They're using a vast bot army. Any single device is every once in a while logging in. So none of the things you do with rate limiting will catch it. And in fact, they're getting very successful. And so you got to do special things now to decide, is that a real human logging in, or is it a bot? And when you discover it's a bot, you don't want to block it because they adapt. You want to say it's an invalid login, even if it's valid, because they're expecting to see it's invalid, because 9 out of 10 maybe are. It's the 1 out of 10 where they make a lot of money and they get a hit on it. And so to do that, you got to use more sophisticated capabilities, and this is where AI and machine learning is becoming, I think, more and more important in cybersecurity, to detect things about the user and their neuromuscular interaction, because it's harder for the bot to fake that. They can log in easily enough, but to fake how a human interacts with a device is harder. And let me show you, some of the stuff we're doing today to make that work. So this is my real cell phone here, and I'm going to pull up the demo. Hopefully we got Wi-Fi. All right. So let me type this in here. Whoops. I got to sync it up. Okay. Now, my device, as I move it around, that is now going through the internet and being recorded and showing up here. And we do this for a huge number of our customers. And every transaction they do, this is happening before the buy or the login happens. And you see that as I move it, the orientation changes. You can see the accelerometer being recorded there. Now, as I do this, all right, I'm touching it and I'm doing something like that to go around. And if I'm going to do signing in here, I've got to get the keyboard, so I'll type in my name here. And you see each time I press a key, that's being recorded, what I'm doing. And then eventually I go to hit login or I go to hit buy. All right, let's see, there we go. Okay, now what's happened is my behavior here, which probably wasn't my normal behavior to buy something, that's what's shown on the left there. And the kinds of things you'll see, bots will try to fake this, and you'll see they'll have different patterns for how they would fake it. And over time, in billions of transactions, we can now automatically and on the fly tell the difference between what's on the left and the kinds of things the bots would do. And then also for the key presses, the keys I press, the time intervals between them, it tends to be different from what a human does and what the bot would do. And of course, when I press the key, that caused this to move. And so that'll be correlated on the accelerometer and how this was oriented. And so we are actually in a very good position today to, in real time, when they go click to buy or click to log in, say, that's a bot. And so now with based on a lot of data and the machine learning, seeing very good results in cutting down on the bank fraud that happens, or people steal your miles, or people steal your credit on commerce sites. It's just a huge organized crime industry today, and so it's a war. To decide, is it human or is it a bot? The guys writing the bots, they're getting more and more sophisticated. All right, so sort of talked so far about your consumer-facing apps. The whole world of enterprise or internal-facing apps is also changing and at great risk. And in fact, today, over half the data breaches were triggered by a trusted insider and a trusted inside device, and not somebody trying to hurt the company. As just a normal person did something by accident wrong. And that's the majority of the data breaches now. It's not even like the Equifax situation where somebody's on a consumer-facing app coming in. Now, the traditional approach to protecting your internal apps, sort of the firewall, the moat around the castle, the corporate perimeter, has been the way you do it. You have your enterprise data center, your apps are inside, your employees are inside, your data's inside, you make your moat, and the bad guy's outside. That's the idea. Now, that world gets a little more complicated as you get more and more people that you need to get access to your internal apps, and you sort of do somewhat, very common but unnatural things by extending your perimeter. You ship them a device, it poke a hole in your VPN to let them in to get access to stuff. That alone is a big source of data breaches. But what happens today is your employee clicks on the wrong thing. And there are things that you can click on today that none of the things you bought will protect you. You know, I can send you an email, I won't, but I can send you an email with a URL in it. It'll be your domain name. There'll be no malware, nothing downloaded. If you click on that, it will destroy some internal app or exfiltrate your data. The whole damage is just in the URL. And the devices you have to protect yourself don't catch this. And it's your domain name. So it's not like it's some bad domain name elsewhere, right? So very, very hard for traditional things to stop. And of course, once the employee's done that, even if when they go to the internal apps, or even if they aren't trying to go to the internal app, once you're infected, you're in big trouble. And this is how most of the data breaches are happening today. It's with a trusted insider. Now, this has led Forrester to say that, you know, the idea of a corporate perimeter becomes quaint, even dangerous. You know, I think this perimeter provides a false sense of security. And it's ubiquitous out there today. This is how you defend yourself. Now, in some cases, you have some extra internal defenses, but for sure, they're much lower once you're inside. And that's dangerous. Now, I think the way you need to think of this going forward is you need to protect your internal apps from your trusted employees just the same way you protect your consumer-facing apps. You would never think about having a consumer-facing app, you know, out to the outside world without having all sorts of protections, authentication, web app firewall, DDoS, so forth. You have all that there. You need to have all that internally today. Same thing, all right? And so, because your employees are still going to click on that link, no matter how many training classes you send them to. All right? I'll confess, a couple of years ago, I clicked on one. All right? And it was really well done, right? It was a personal inside email from someone when I was expecting to, you know, get exactly this. Okay? And it was malicious. It's going to happen, but if you protect your internal apps from your internal employees, as if they're not trusted, well, you can be okay. They don't necessarily kill your apps. This is the world of zero trust. I would imagine probably you've been talking about that here. You know, some folks talk about it as Beyond Corp, but it's a whole different way of thinking about enterprise security. And it's going to take time for the change to happen, but this is the way I think you need to be thinking, you know, to stay out of the headlines. You know, we have a service now with our Kona service. We're now making this available for internal apps. And we had one of our early adopters is one of the world's largest airlines. And in the first week, when they turned it on, we had over 75 attacks that we blocked and discovered from trusted inside employees and devices. Just in 1 week, the first week, all those attacks came from trusted insiders. And those were going through before. All right, I think it's shocking what's actually happening that folks don't know today. Also, it's good to be thinking about your employees and data to the extent you'd like to stop the person from getting infected when they click on the wrong link. And there's things that can help with that today. You know, we have a new service called Enterprise Threat Protector, and this works at the DNS layer, the recursive DNS layer in the enterprise. A lot of folks don't even think about DNS. You know, a lot of the people I talk to at companies don't even know how they run their recursive DNS. And probably it's freeware, because recursive DNS just does the resolution of the domain name to the IP address. It's just a basic function on the internet. That is a great place to be providing security and blocking lookups to bad places so that you don't get infected in the first place. Now, by itself, it's not foolproof, but it catches a lot and stops a lot of bad things from happening. Another way it's useful is, say you do get infected and you have malware on the inside. Well, the malware often needs to exfiltrate your sensitive data, and often to do that, it's got to do a DNS lookup. And because it's got to find the botnet for exfiltrating the data to. And those botnets have to move around, and so there's a DNS lookup. And so you can catch it if you're applying security at your recursive DNS layer. In fact, we've got a lot of the early adopters of this have discovered malware, in their enterprise in the act of exfiltrating their sensitive data, just through the DNS lookup. And a really good example is a very famous fashion brand in Europe turned it on, and it discovered that their HVAC system was exfiltrating their sensitive corporate data. Now, you think, they probably weren't even thinking their HVAC system was on the corporate network. But of course, everything is, right? Everything's connected, and you want to be managing your temperature controls automatically. But it's not a thing that you're focused on necessarily for security. And of course, the bad guys know this, so they get in there, they infect it, and that's what they were using to collect all the data and then ship it out. And of course, their HVAC system shouldn't have been doing any recursive DNS lookups, never mind to a botnet known for data exfiltration. All right, so, in summary, defense in depth is more important than ever. There's not one solution. And you got to be leveraging, I think, today, cloud defenses to provide scale and to keep the attackers far away from your data center. So using cloud-based security services over and above whatever you would put in your data center. And today, if you're relying on something in the data center to protect you, it probably is too late, and you're not going to be able to succeed at scale. I think it's really important to adopt a zero-trust mindset. You can't trust anybody in your organization, not your CISO, not your CEO, because they can click on the wrong thing. They can go to the wrong place. They can be exploited, no matter how smart they are. You just have to protect your internal apps the same way you would external apps out in the wild. And it's much better if you think of it that way. Just sort of forget you had a firewall, because it really is not solving the problem today. And think about your internal DNS infrastructure. How are you running it today? Is it secured? Because that's a great place to put security to stop being infected, once you are, to block the data from going out. It's also sometimes used as a vector, actually the DNS query, to exfiltrate data, because you're not usually inspecting that. Okay, thank you very much.